Hey folks, welcome back. In this video we're going to go over question 1 from the 2018 SQA Advanced Higher Physics exam paper. So let's get started. Question 1 here says energy is stored in a clockwork toy car by winding up an internal spring using a key. The car is shown in figure 1a. The car is released on a horizontal surface and moves forward in a straight line. It eventually comes to rest. The velocity v of the car at time t after its release is given by the relationship v equals 0.0071 t minus 0.00025 t squared, where v is measured in meters per second and t is measured in seconds. It then says using calculus methods for part A, determine the acceleration of the car 20.0 seconds after its release, and you'll see there's 3 marks available. Well, remember we're given an expression for velocity v, and we want to determine acceleration, so we're going to differentiate v with respect to time t. So we can write that A equals dv by dt, that is, acceleration is equal to the rate of change of velocity, and remember that expression is on your relationship sheet. And we can say that is the same as writing d by dt of 0.0071 t minus 0.00025 t squared. Or in other words, we want to differentiate the velocity expression with respect to time. So remember, to differentiate, you want to bring your power down and multiply by your number, and then remove 1 from the power. Differentiating this gives us 0.0071 minus 0.0005 t, where we brought the 2 down to multiply by this number and removed 1 from the power, so that stays as t. Now we're given a time of 20.0 seconds, so we now want to substitute the time value. So we have A is equal to 0.0071 minus 0.0005 times 20.0. And putting that into your calculator should give you an answer of minus 0.0029 meters per second squared. Part B says to determine the distance travelled by the car 20.0 seconds after its release, and again there's 3 marks available for this. Well, remember we're given an expression for velocity in the question, so in order to get distance or displacement s, we need to integrate this time. So we want to integrate velocity v with respect to time t, so we can rewrite that v is equal to ds by dt is equal to 0.0071 t minus 0.00025 t squared, where all we've done is rewrite v as ds by dt, which is an equation on your relationship sheet. So we can now ignore the v and integrate both of these sides with respect to time, so we have the integral of ds by dt dt is equal to the integral of 0.0071 t minus 0.00025 t squared dt. So the integral of velocity with respect to time just gives us displacement s on this side, and that is equal to, well, for this first term, remember you want to raise the power by 1 and divide by the new power to integrate. So we have 0.0071 t squared divided by 2 minus 0.00025 t cubed divided by 3. Plus c, where c is our constant. So to find out what our constant c is, we need to consider the initial conditions, which remember is just what happens when time t equals 0. So at time t equals 0, we can say the displacement s of the car is 0 because it's not moved yet. So if we sub in t equals 0 into here, then these two terms become 0, and if s is 0, then that means c is equal to 0 as well. So we can just rewrite our displacement s as s equals 0.0071 t squared over 2 minus 0.00025 t cubed over 3. And remember we're given a time in the question, 20.0 seconds, so let's sub that into our expression for s now. So lastly, we want to substitute the time value, so we have s equals 0.0071 times 20.0 squared over 2 minus 0.00025 times 20.0 cubed over 3. And if you put that into your calculator, you should get an answer of 0.75 meters. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.